All right, in today's lesson, we're going to learn how to balance redox equations in basic solution. But before we do that, there was one problem that I did not assign to you yesterday when you were balancing acidic solution problems, because it had an extra little twist to it, and so I was afraid it might confuse you, so I wanted to go through that one first. That's extra practice problem number 5, and so if you want to flip to it, you may. But basically what they did is they gave you this problem, and they said this reaction takes place in acidic solution and you should balance that. Now, when you initially look at that, it probably looks a little confusing because there's only one thing over here. But I got 3 things on the left-hand side. What am I supposed to do with that? The main reason that I'm teaching you the method that I am is because when you have to go through and assign oxidation numbers to everything in the reaction, which is the way that Dr. Weil teaches you to do it, it's a perfectly valid way, and in fact, it's the way that I learned to do it initially. But the method that I'm teaching you prevents you from having to assign oxidation numbers to everything within the reaction, and it's just another way to eliminate a possible source of error. And there's so many places in these where you can make a mistake, a simple addition error or multiplication error, and you've got everything messed up. However, to try to show you what's going on in this equation, I'm going to go ahead and assign oxidation numbers to everything. All right, so with the lead, I have a 0 because it's by itself. With oxygen, you'll remember that it's a -2, and so since I have 2 of them, that's a -4, so that means that lead has to be a +4. Here I have a sulfate ion. This is one of those polyatomic ions that you should have memorized. It has a -2 charge on it. You know that oxygen is a -2, and so that means that my sulfur has to be a +6. Now, if I look on the other side, the sulfate is still a -2. Just as a unit, it's a -2. So this is still a -2. This is still a +6. But since this has a -2, this lead is going to be a +2. All right, so as you can see here, the sulfur and the oxygen never change charge throughout the reaction, but the lead changes twice, because here we're going from a 0 to a +2 where it's been oxidized, and here this is going from a +4 to a +2, so it's being reduced. So I've got the same element that's being both oxidized and reduced. So what that means is that I'm going to have to use this twice. So to write the half reactions for this, I'm going to have this lead that's going to be going to lead sulfate. But in all of our rules for balancing these equations, we never had anything for balancing sulfurs. It's only oxygens and hydrogens that we had rules for how to balance those. But since this sulfate isn't changing oxidation numbers, I can just add this ion to this side, okay? So there's the first half reaction. The second half reaction, the lead is being, we said the lead was being reduced. And again, I've got to have a sulfur from someplace, and so the only way to get that sulfur is to use that, okay? So those are the spectator ions that are in solution. They're not part of the redox, but you have to have them in there in order to balance the rest of the equation. So I'm going to stop right there now, now that I've given you the half reactions, and I'm going to let you finish this problem as part of your homework today. So if you want to write down those half reactions before I get rid of them, you may do that. And then we're going to move on, and I'm going to teach you how to balance redox reactions in a basic solution. Balancing redox reactions in basic solution isn't really any harder. It's just that there's a couple of extra steps, and you have to really be on your toes as far as arithmetic so that you don't make any mistakes, okay? So again, if you take your sheet and make sure that you're following through step by step, doing everything in the right order, you should be fine. I'll show you one so that you can see how to do it. So we're going to start out by writing our 2 half reactions. We're going to go iron to iron hydroxide. And then we're going to go MnO4 minus to MnO2. All right, so we'll start with this one up here. The ions are already balanced. And the next thing I want to balance is the oxygen. So I have 2 oxygens here. So that means I'm going to have to add 2 waters to this side. Then I have 4 hydrogens here and 2 hydrogens here. So I'm going to have to add 2 hydrogen ions to this side. Okay, now I'm going to have to balance charge. And so I have 0 on this side, positive 2 on this side. So I've got to add 2 electrons over here. Okay, so far this is the same thing that you've already seen, and so you should be okay. All right, now we're in basic solution in place of acidic solution. So when we're in acidic solution, we have extra hydrogen ions floating around. In basic solution, we have extra hydroxide ions floating around. Well, how can I switch this up? Well, if you will remember, if I take a hydrogen ion and a hydroxide ion and I add them together, that gives me a water, right? And I have lots of waters floating around in solution. So what I'm going to do is, for however many hydrogen ions I've added, I'm going to add the same number of hydroxide ions to that side of the equation so that I can add them together eventually and make water. So, but once I add hydroxide to this side of the equation, now I have to go and I have to add hydroxides to this side of the equation as well, because otherwise I would have messed up both my charge and my number of atoms. Okay, so that's the first step there that's different. Now, when I do my manganese, I have the same number of manganese on both sides, but I have 4 oxygens on this side and 2 on this side. So I'm going to add 2 waters over here, so my oxygens are balanced. I have 4 hydrogens here, so I need to add 4 hydrogens on this side. Now I need to balance charge. I have a positive 4 and a minus 1, which is a positive 3, 0 on this side, so I need to add 3 electrons to that side, to the same side, okay? Again, though, I'm in basic solution, so if I've got 4 hydrogens, I need to add 4 hydroxide ions here. If I do it to one side, I'm going to have to do it to the other side since I already had it balanced. Okay? All right, so 3 electrons here, 2 electrons here, least common multiple is 6. So that means I'm going to need to take this whole equation and multiply it through by 3. And I'm going to need to take this whole equation and I'm going to need to multiply it through by 2. Okay? So, I multiply this through. Again, just watch your arithmetic and make sure that you don't make any silly mistakes. So we're multiplying the top equation by 3. So that's going to make that a 6 and a 6 and a 3. Then I'm going to have a 3 in front of the iron hydroxide. And I'm going to have 6 hydrogens and 6 electrons and 6 hydroxides. Okay? 6, 6, 6, 3, 3, 6, 6. Okay, make sure I didn't make any mistakes. Okay? Second equation, I got to multiply through by 2. So this is going to be 8 plus 6 plus 8 plus 2. Then I'm going to have 2 of these plus 4 of these and 8 of those. Okay, 8, 4, 2, 2, 8, 6, 8. Okay, so hopefully I multiplied everything through right. If not, we'll discover it later when I may have made a huge mistake. Okay, so let's go through and see what we can cancel out. I have 6 electrons on both sides. Now, if your electrons didn't cancel out, that's your first huge sign that something is wrong. You've got to make sure your electrons cancel out on both sides. All right, so what can we combine together here? Well, If you remember, I told you that hydrogen ions and hydroxide ions add together to make water. So here I have 8 hydroxides and 8 hydrogens on this side. And then over here, I have 6 hydrogens and 6 hydroxides on this side. Okay, so I'm going to combine those together. And let's see what I'm going to end up with. So I'm going to have 6 OH minus plus 6 H2O plus 3 Fe. That's from the top half reaction. The bottom half reaction, I'm going to add these two together. So I'm going to have 8 waters and 2 permanganates. Okay? Then on the right-hand side, I have 3 iron hydroxides. The hydrogens and the hydroxide ions are going to add together, so that's going to give me 6 waters. Okay, see where that came from? 6 of those and 6 of those make 6 waters, plus 2 MnO2s, plus 4 waters, plus 8 hydroxides. Okay, am I done? No, because I have a whole bunch of things that I can now cancel out. I can add like things together to get it all simplified. So if you notice, if I look at the left-hand side first, I have waters in 2 different places. I have 6 here and I have 8 here, and that makes a total of 14. So I'm going to get rid of this one. I'm going to change this number to make a 14. Okay. On the left-hand side, I have 6 waters and 4 waters, which then are going to add together to make 10 waters. Okay? Now, what can I cancel out on each side? Well, I had 14 waters on this side and 10 waters on this side. So here I can cancel them out completely. So here I'm going to get rid of these 10 waters, and that's going to leave me with 4 over here. All right. Then I have 6 hydroxides here, and I have 8 hydroxides on this side. So I'm going to cancel them out as well. So I'm going to get rid of these 6, and I'm just going to have 2 left over here. All right. So I think I've got everything canceled out. So when I finish this up, then I'm going to have 3 Fe's plus 4 H2O's plus 2 MnO4 minus yields 3 iron hydroxides plus 2 MnO2 plus 2 hydroxide ions. Okay, so now I need to go through and be sure that I have everything balanced. So I'm going to start with the iron because it's the easiest. I have 3 irons and 3 irons. I have 2 manganese and 2 manganese. If I check my oxygens, I have 4 here and 8 here, which makes 12. And then I have 2 times 3 is 6 here, plus 4 here, which makes 10, plus 2 more, which makes 12. Okay, so I got 12 oxygens on each side. Then when I check my hydrogen, I have 8 on this side, I have 6 here, and 2 here, which makes 8 on this side. All right, then finally I need to, all of my atoms are balanced, so then I need to check charge. So I have a -2 on this side, and I have a -2 on this side. Yay, everything is balanced. Now, places where students commonly make mistakes, places where teachers commonly make mistakes, because I have done this. In fact, when I worked this problem the first time I did this, you need to be sure that you cancel out everything on the bottom. You don't want hydroxides on both sides of the equation. You don't want waters on both sides of the equation. You need to make sure that you only have water on one side, that you only have hydroxides on one side to keep everything canceled out. Okay, so you have to really watch your arithmetic and watch your canceling to make sure you get everything canceled and you get this down as simplified as you possibly can. So really the only difference here between balancing these and balancing acidic one's an acidic solution is that once I've added my waters to the half reaction to balance the oxygen, and I've added my hydrogen ions to balance the hydrogen, you're still adding electrons to balance charge. The extra step comes then when however many hydrogen ions you've added, you have to add the same number of hydroxides to both sides, okay? Then when you bring that down, and then when you start simplifying everything, remember that hydrogen ions and hydroxide ions add together to make waters. And then once you get down to this step, then it's just long and messy and you have to make sure you cancel everything right, okay? So the next couple days now, today and tomorrow, you will be working on solving these in basic solution and being sure that you can get those balanced and simplified all the way, all right?